Hello and welcome to yet another thrilling installment of the geometry videos. This is section 5, and this is a section about using triangle similarity theorems. And so what I want to do is first kind of ask this question. How can similar triangles be created by drawing lines through a triangle? So one thing I'd like to do is kind of zoom in on this picture here and notice that we have this big triangle ACD, okay? And then inside of that, let's say that I came along segment AC and segment AD, and let's say I plotted the points B and E. And let's say that if I were to connect those 2 points with a line, okay, and let's say that that line is parallel, that BE is parallel to CD, then what we can say then is that triangle ACD is similar to triangle ABE, okay? And we'll talk about that and why that works, okay? And the reason why is because of this thing called the Side-Splitter Theorem, okay? And what the Side-Splitter Theorem says is that if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally, okay? And so we could do this a couple of different ways. What I would do is, given this scenario, given triangle ABC, okay, and let's say you have line DE, and line DE is parallel to line AB, then what I know is that if I were to take segment AD, which is this segment here, okay, if I take AD, and let's say I divide AD by, say, DC, okay, then that would be proportional to saying BE, okay, BE divided by EC, okay. Now, there's a couple of other ways you could do this. You could even, this is just one way of writing this proportion, okay. Another way that you could write this proportion, it would be to say if you took segment AD and divided that segment by segment BE, okay, then that would be equivalent to us saying that segment DC divided by segment EC, okay. So there's a number of ways of doing this. Any sort of combination that you can make with these fractions, and that's something that you could play around with and just verify that these are, in fact, proportional sides, okay? So let's go ahead and do this, and it says find the length of VT, all right? So what I have is I have the scenario where I have this picture, I have triangle STU, okay, and then I have the smaller triangle SVW, okay? And what I end up having here is because these two lines are parallel, then I know that these sides are divided proportionally. All right, so what I'm going to do is I'm going to call this length over here VT. I'm going to call that X, okay? And so what I want to do is then I'm going to divide these proportionally. I'm going to kind of color code them again. So I'm going to take segment WU. I'm going to color that red. I'm going to take segment WS, color that blue. Okay, segment SV, color that blue, and then segment VT, color that red, okay? And you can do this a number of ways, but I'm going to go ahead and do this small segment divided by this big segment, okay? That's how I like to set these up. So I'm going to do 7 divided by 10, okay? And that's equal to me doing X divided by 9, okay? And so now what I want to do, in order to solve this equation for X, you could cross multiply and divide, and that would work for this scenario, but sometimes these get a little trickier. So we want to use the cross product property that we learned in the last section. Okay, the cross product property. And so what I'm going to do now is I'm going to multiply 10 times X and 7 times 9, okay? And that gets rid of my fractions. So I'm going to do 10 times X, and that's equal to 7 times 9. okay? Now 10 times x is just going to give me 10x. But 7 times 9, that's going to give me 63, okay? Now if I'm going to solve for x, I'm going to divide both sides by 10 and by 10, so then I get that x is equal to 6.3, okay? So then since x is equal to 6.3, then I can then say that segment VT has a length of 6.3, and that's it, okay? So that's what we're doing. So you got to be able to look at a picture, okay, understand what's going on, and then set up a proportion, and then solve for your missing side, all right? Okay, so then we have the converse of the side-splitter theorem, okay? And what that says is that if a line divides a triangle proportionally, then it is parallel to the third side. So let's just say this. Let's say that this is a 1 and a 4. Okay, that AD, this segment is 1, and that DC has a length of 4. Okay, and then let's say that BE is, say, 1.25, okay? Let's just say that, and then let's say that EC has a length of 5, okay? Now, if I were to come in here and say, okay, if I take 1/4, okay, this length divided by this length, this is going to be equal to me doing 1.25 divided by 5, all right? So 1.25 divided by 5. All right, and so what I want to do is I'd want to multiply across. So if I multiply 4 times 1.25 should be equal to 1 times 5. All right, and if I take 4 times 1.25, so 4 times 1.25, then I should get 5. I get 5, and that's equal to 5, okay? So the sides are proportional. So when I do this, I verify that the sides are proportional, okay? And if the sides are proportional in this situation, proportional, okay? If the sides are proportional, then I can conclude that segment AB, all right, segment AB is parallel to segment DE, okay? And that's what I know, that those sides are parallel, okay? That's the converse. All right, so let's apply this a little bit and make sure that we can understand this and do the algebra that's required for this. So what I want to do is I want to apply the converse of the side-splitter theorem. So what I want to do is determine a value of x that would make DF parallel to GH. So if these are parallel, then I know that these sides are proportional. Okay, so I'm going to color this in red here, and then color the next one in blue. Color this one in red, just so I have these all squared away. All right, color that in blue. And so I'm going to take this big segment and divide it by this little segment. So I'm going to take x plus 3, okay, x plus 3, and divide it by x minus 1, okay? And then set that equal to, I'm going to do x plus 6, okay, and then divide that by x. Okay, now what I'm going to do, I need to solve this for x. I need to cross multiply, okay? So this is where just cross multiplying and dividing doesn't really work. This is where you need to actually set up an equation. So I'm going to cross multiply these two, all right? And so if I take the quantity x minus 1 and multiply it by x plus 6, and then I'm going to take x plus 3 and multiply it by x, okay, then what I'm going to do is I need to solve this for x. Now, this is a little tricky to solve this for x. This requires some algebra, and what we need to do is multiply this out and FOIL it. So I'm going to multiply x times x, which gives me x squared, okay. I'm going to do negative 1 times x, which gives me a minus x. I'm going to do an x times 6, which gives me a positive 6x. And then negative 1 times 6, which gives me negative 6, okay? And then here, I'm going to distribute my x, so I've got an x times x, so I get an x squared here, and then x times 3, which gives me plus 3x. Okay, now the nice thing about this is that this is kind of the hard part of doing this problem. But when we solve this for x, what we want to do is we want to get all the x's on one side and no numbers on the other, all right? And I'll show you why, all right? If I were to subtract an x squared from both sides here, then this actually cancels out, okay? What I end up having here, x squared minus x squared goes away, and that goes away, which is nice, okay? That's kind of the heavy algebra portion of this problem that's kind of gone. And so now what I want to do is then still combine my like terms. So I have a negative x plus 6x, and that's going to give me a 5x. So I have a 5x minus 6 is equal to 3x, okay? And then I'm going to subtract a 5x from both sides, so minus 5x. So those cancel out. All right, my next step, I'm going to get negative 6 is equal to negative 2x. And then I'm going to divide by negative 2, divide by negative 2. So I get that x is equal to 3, okay? And that's the value that would make my lines, that would make these sides proportional, which would then make DF parallel to GH, okay? So in a type of problem like this, you know, you really just want to set up your proportion and go about your day, all right? And, all right, so now the next one says that we're talking about the midsegment of a triangle, okay? And the midsegment of a triangle is something that is a segment that connects the midpoints of two sides of a triangle, okay? So what I would do is if I were to find the midpoint of each of these sides of this triangle, RTS, okay, midpoint of TR is this point U, okay? And I know that because TU is congruent to UR. V is the midpoint of SR, and I know that because SV is congruent to VR. And then W is the midpoint of TS, where TW is congruent to WS. Now, the midsegment is the segment that I create between these 2 points. So if I connect WU, that's a midsegment, okay? If I connect UV, that's another midsegment. Okay, and then if I connect WV, that's another midsegment. Oh, look! Another triangle. Isn't this fun? I'm having a good time. This is great. All right, so now what I know about the triangle midsegment theorem, okay, the theorem that we're given is that the midsegment of two sides of a triangle is parallel to the third side. Okay, so if I have a midsegment, okay, if I have this big triangle here, all right, if I take segment AB and cut it in half at point D, and take segment EC and cut it in half at point E, okay, so I have two congruent pieces here, two congruent pieces here. Not only do I know that DE is parallel to BC, okay, is parallel to BC, but I also know that DE is half as long. So DE is equal to 1/2 the length of BC, okay? And that's all, and that's what I'm looking for, all right? So we need to use that. So if we know that, if we see a picture like this, we can automatically conclude these two things, okay? So let's go ahead and take a look at that and apply this theorem. And it says if F is the midpoint of CD, okay? So if it gives me that information, you know, what do I need to do on this picture? Okay, and I'm going to divide this up into two congruent parts, okay? And then it says G is the midpoint of CE, okay? So I'm going to come over here and say that CG is congruent to GE, okay? And so then what I know is that it wants me to find DE, it wants me to find this length. Well, what I know, based off of this information, is that FG is half the length of DE, okay? And that's what I've got. So FG is 4x minus 1, okay? And I know that that's 1/2 the length of DE, which is 6x plus 4, okay? And let's go ahead and solve this for x so I can find what DE is, okay? So I'm going to go ahead and distribute this 1/2, all right? And so I get 4x minus 1 is equal to 1/2 times 6x is 3x. and then half of 4 is 2. Okay? So then I'm going to subtract 3x from both sides. All right, so I can solve for x. Those cancel out. I'm left with just a single x on the left side. X minus 1 is equal to positive 2. If I add 1 to both sides, then I get that x is equal to 3. Okay? So now that I found that x is equal to 3, I can figure out what dE is. Now dE, remember, was 6 times x plus 4. All right, so if I plug in 3 in for x here, okay, I can find that dE is equal to 6 times 3 and then plus 4. So we get that 18 plus 4, and that's going to give me a length of what? 22? So dE has a length of 22. Okay, so just using these concepts and understanding what all these theorems mean and all that is really going to be useful in you solving problems. So, hope you enjoyed this video. We'll talk to you soon. We'll see you later. Bye.